Thank you for the opportunity to present here my business 1.5 or more than 1 year after being acquired by Mycronic. The business unit is headquartered in Germany and has a strong presence in Asia, with roughly half of its 190 employees being based there. Now the next slide should come. We develop, manufacture and sell equipment for the electrical test of bareboard, it means unpopulated PCBs, and of substrates. Where that puts us in the value chain can be seen here on the slide. As Clemens mentioned, PCBs can come in many different flavors, starting from small flexible PCBs which go into hearing aids or pacemakers, up to PCBs more than a meter wide, 40, 50 kilos heavy, 70 more layers, which go then into applications like telecoms infrastructure. In contrast, substrates are small structures which interface silicon die with PCBs, and they are therefore part of the semicon packaging process. Although the structures are much smaller and denser, those substrates are technology-wise very much comparable with PCBs and often made from the same organic materials. PCB manufacturers and substrate manufacturers use our equipment in their quality control process, mostly to identify defects and faults on the PCBs and substrates. These are mostly opens and shorts, but advanced test methods also identify other faults which provide the manufacturer with important feedback for the manufacturing process. We offer 3 product lines for this application. One is the flying probe test system for PCB test. The second is the flying probe test system for substrates, and then fixture-based test systems for high-volume PCB test. The flying probe test systems do not require a PCB-specific interface to test the products. Instead, the design data of the PCB is used to derive a test program, which provides then the system with the information where to put the probes on the PCB to do the measurements. In contrast, fixture-based systems require an interface which mirrors the structure of the PCB. It therefore takes time, effort, money to set up a new PCB or new PCB design, but at the same time it allows far faster test, and therefore fixture-based systems are mostly used for high-volume test. Flying probe test systems can be used for prototypes, samples, low quantity, high mix production, but also for all applications where there is a good reason not to build fixtures. For example, server boards are normally too big and complex for fixtures, and these are all tested on flying probe systems. In the market of flying probe systems, we are market leader in most countries and for most applications. Flying probers contribute roughly 80% to our system sales. In the market of fixture-based systems, we are a smaller player and concentrating on profitable niches. Let me go into some more detail of our flying probe technology, because we do have there a unique design which gives us a competitive edge. Competitor products are always built based on so-called plotter systems with linear XYZ movement. Our systems cover one of the dimensions by rotating the test head. You will see that in a minute in a video. That allows us to deploy many more test heads in a system. So ours can go up to 24 test heads. Plotter-based systems normally are restricted to 4, maximum 8 test heads, and having therefore much lower throughput. Another differentiator of ours is the fast automation with integration into the factory systems. That together with the high throughput of our electrical test allows our customers to test larger quantities with flying probers than they otherwise could achieve. Let me show you a flying prober then in action. Sorry, that was once too many. So now, this is an automated flying probe system for PCBs. It has a pick-and-place system for loading, unloading the PCBs into two shuttles to parallelize some steps. Once the PCBs are in the shuttle, they are driven in a test position where the PCBs are first scanned to identify the exact location of the PCB in the machine, and then the electrical test can start with 8 test heads here in this case, 4 on the top side, 4 on the bottom side. After test, the products get unloaded. Here with those smaller PCBs, the two PCBs are handled in parallel in 2 shuttles. Once the PCBs under test are bigger, those 2 shuttles are moved in synchronized mode as one large shuttle. In a second video, I show you the test of substrates with the flying probe test system. This is a manual system, which means that the PCB is loaded and unloaded manually into the machine. But otherwise, the process is very much the same as you have just seen with the PCB. What's different here with the substrate tester is that it's far more accurate. So the pads which get contacted can be as small as 15 micron. And the test heads you see, they can touch down on 30 pads per second and do equally many measurements. So this high stroke rate together with the number of test heads we are utilizing gives these machines unmatched throughput. With that, let me come to fixture-based tests. I'm showing here the most recent model, the LM1000. It has a granite base, linear drives, and allows the customer to choose between 2 different fixture designs and concepts. In the end, allowing the customer to choose always the most cost-efficient fixture possible. I show you this machine also in a short video. Similar to the first video, you see here also a pick-and-play system for loading and unloading. Oh, you should see. Once more. Okay, now it comes. So for the loading and unloading pick-and-play system, again, 2 shuttles driving the PCBs into the machine. Here, scanning and testing get parallelized. This is a fixture with thousands of pins here sticking out, which allow then the parallel contacting of the nets and therefore the measuring of the PCB in really one go. PCBs with several images normally get stepped in this machine. Product category at which the LM1000 really excels at because of the stepping required is the category of micro LEDs, mini LEDs. I have now spoken a lot about technology and the edge we have with ours. But apart from the hardware, also the application itself is really important for our customers to achieve their objectives. And this is an area where we cooperate closely with our customers, so to continuously develop our applications and ensuring that these applications meet the future needs of the customers. An example for that is the most recently developed back drill test, which we developed together with a large customer in the US. This addresses some test requirements for high-frequency boards, and it's now spec'd in by one of the really major OEMs. There's on the one hand side this way of cooperating with customers, but at the same time there's our strong belief that we can only be as successful as our customers are, and that is really reflected in our day-to-day behavior. And this overall might be responsible for the long, deep customer relationships we have. When looking at our top 20 customers, we are working together with these already for more than 22 years. And it goes without saying that we need to be present where our customers are to achieve this. And we do have our own employees in all major production hubs worldwide, or are present with long-time partners like in Korea and Japan. We try to do this all while at the same time preserving the resources, and here I'm referring back to Lena's and Christina's presentation, and will not elaborate in detail. Instead, let me show one slide on the market development. The market research company Prismark is showing a 4.8 CAGR for the PCB industry for the time up to 26. But apart from the market size of our customers, there are other forces at play determining the demand for test equipment. There's on the one hand side the drive of our end customers for zero defects. At the same time, there are more and more complex PCBs with denser structures, higher frequency signal nets, and all that in the end leading to more tests and more demanding tests, and in the end therefore leading to higher demand for test equipment. Many of these trends even favor flying probers over grid systems, fixture-based systems, and that because since we are especially strong on the flying probe side and have a strong market position, that should help especially us. So we are therefore looking ahead into the future with a lot of enthusiasm, and this brings me to the end of the presentation, and thank you for your attention.
Okay, thank you. So again, my name is Mike Chalsen, and I head the division, and I'm going to be talking about the die bonding business unit, which is the second of the two units within GT. And that came in under the MRSI acquisition in 2018, so we've been under Mycronic for 4 years now. Okay, so I'm going to start off with a video which gives you a quick preview of the die bonding business.
Breakthrough technology is driving global changes in communications, in medicine, in aerospace, in consumer electronics, and in transportation. And the pace of finding the next great breakthrough is accelerating. Smaller and smaller parts have to be assembled in an increasingly more miniature package at lightning speed to support these generational changes. A trusted partner to the creators of tomorrow's electronics, MRSI provides fully automated die bonding and dispensing systems for microelectronics and optoelectronic packages with world-leading flexibility, speed, accuracy, and reliability. Our people are our prized asset, both in the factory and in the field, working with our customers on our common goal to create purposeful innovation. Backed by a culture of knowledge sharing and support, MRSI's experienced engineers design elegant systems by understanding the customer's process and the business requirements, and have been doing so for over 35 years. And to ensure continued success, we deliver 24/7 support through our global field service team. MRSI is backed by Mycronic Group's power of innovation. We're working together to extend the frontiers of electronics technology, ready to find the next great solution, the next great breakthrough, bringing tomorrow's electronics to life.
So what is a die bonder? A die bonder is a machine that picks and places bare chips into packages. And similar to the high flex pick and place machines, but high flex would be a surface mount, which would be already encapsulated bare chips that go down onto the board. We're one level behind there where we're actually taking chips and putting them into packages with high precision. Die bonding market is huge, and we're addressing a segment of the ultra high precision part of that market. So again, it's bare chips going down into packages, and usually those packages then get built up into higher level assemblies, which I'll talk about some of those markets. And you can see here, we're in the back-end packaging. If you look at the semiconductor markets, the front end would be where the wafer's being manufactured, including SLX. That product line is on the front end, right, manufacturing wafers. The back end would be where the chips are taken off of the wafer and put down into that package, as I mentioned. And they could come in wafer formats or also tray format. And the end product of our customers would be the package. So our customers are using our equipment to build up the packages that then they would sell off or integrate into higher level assemblies themselves. So the first market, which is the biggest market for the die bonding business, is the communications, which is the data telecom markets. And those markets that we serve would be the 5G wireless. And the bigger segment of that market would be the data center markets that we serve. And the platforms that we build, I don't know, that video should be running too. The platforms that we build are taking the small devices and putting them down into packages. And one of the biggest segments in the data center part of the market is these transceivers, which is that long device with the green part at the end. It's about the size of a thumb drive. And those are transceivers. And every data center has over 1 million transceivers in a data center. And that's the device that does the conversion of photons coming off of the fiber internet, right, the fiber going into the data center, into the server, and then it gets converted into electrons, and the processing is done within the server, and then it has to go back out onto the internet, so it has to get converted back out to light, photons. So these transceivers are doing the conversion. So there's photodiodes in there, there's lasers, there's optical devices and lenses. So our machines are integral to this engine manufacturing, this optical engine that goes into that transceiver. And we're putting parts down into single-digit microns, so 2-3 microns accuracy, because when you're dealing with light, you need to be accurate. And the parts themselves are small. It could be like the size of a grain of pepper that we're handling down into accuracies of a micron or so. And now we're getting into sub-microns, so we're placing chips in half a micron for some of these higher-end applications with higher bandwidth. So that's a big segment for us, and as you know, that market's growing. Right, and it continues to grow. It was growing before COVID, it grew during COVID, and the growth charts are still double-digit growth post-COVID because of the way we work, right? Everything's online now, et cetera, et cetera. Our customers, like Lumentum and Innolight, a lot of these are Asian-based customers, are selling directly to the big guys like Google, Facebook, Amazon, Microsoft, who are building data centers themselves. So they don't go elsewhere, they don't go out to build their data centers anymore. They're all doing it themselves, and they're buying these optical devices from our customers. So we're just 2 levels away from these guys. The second biggest market, and this is kind of where we, as a die bonding business, kind of grew our roots in the aerospace and defense markets. And again, if that video was moving, you could say the head is picking and placing small chips from these little trays into a package. But you can see there's many different types of trays. So unlike communications market where we're doing maybe 1 or 2 different die type, here we're placing, could be multiple dozens of different parts coming from these different trays and with all different patterns, patterns on the die that we'd have to recognize with vision. So we grew all the vision algorithms and all the database foundational software from this market, and we just applied it to higher speed platforms to serve the higher volume communications market. So a lot of the technology basis came from these earlier markets, but they're still a significant market for us now. And we're selling to customers that are building like satellites, these advanced radar, digital radar systems, again, using transmitters and receivers, like digital devices that plug into these radar systems. So again, high accuracy gallium arsenide devices for the microwave. So different components, but the same idea in terms of transmit, receive. And then also on the medical side, we sell to customers like GE that are building scanning systems for scanners. So we're placing the high density sensor into a package in this case. And then we support governments on their aerospace and defense, and then hospitals and care centers. And then the third market would be the emerging markets. And here we're excited about these because these are kind of the higher growth markets for us that we see. A lot of them are still in their infancy. But again, capitalizing and utilizing and leveraging our high precision, bare die, delicate high volume type capabilities, we're getting into applications like LiDAR, VR, AR, automotive, and consumer markets, again, building in a lot of cases, these optical engines that go into these higher volume devices now that support, again, the end products being smart devices and VR and AR, which would then go into, to be bought by automotive companies, tier 1 players, and also companies like Apple and Facebook. So this is an exciting segment that we see growth capabilities out of. So looking at all those markets, we're looking at addressable market basically doubling in 5 years to about $660 million is what we're looking at. And the drivers, we've heard it in the other presentations, a lot of common drivers, 5G, communications, the way we're working is different now, so we're seeing a lot of more internet bandwidth requirements. All this is driving that. We're looking at the miniaturization of parts, so the small parts fall right into our expertise. The ability to do flexible type assembly. Again, the background in terms of the ability to do quick changeover, even in our industry, is very, very important, and that will, again, support the addressable market growth that we're seeing. And then after 36 years of doing die bonding, but we've become really well known and pretty good at this very high accurate, flexible, reliable machines. Again, starting off with aerospace and defense, we heard that chips going into satellites, very important that it's reliable. And then adding on the high volume capability of new products that we introduced about 6-7 years ago to support the communications market gives us the fourth leg there, gives us really a great position amongst our competitors, which are some large companies, but then also some mid-size and smaller companies. Very niche-y, some of these areas that we play in. So our goal is to become a technology and market leader in attractive electronic niches. And again, we're going to be seizing opportunities organically within the current business units that we have, the test and also die bonding. But then as you also heard, that we're looking at M&A, and we're looking at product line extensions, we're looking at market extensions, but we're also looking at kind of standalone-ish type acquisitions as well. And GT will be the division where a lot of this activity will happen in terms of pulling in, incubating companies, and then they either go out to their own division or go into another division, existing division. So thanks for your attention.